In this video, we will look at how to structure an application in JointJS Plus. We will provide some alternative suggestions to what you might be familiar with if you have already looked at some of our tutorials. And finally, we will look at some of those ideas applied to our Mindmap application, which you can currently see on screen now. So before looking at the Mindmap application in more detail, we will look at some of the features and setup in isolation to get a better sense of how we might structure a project in JointJS Plus. Now on screen we are looking at a bare bones version of the Mindmap application. So it doesn't contain any shapes, but it does contain enough to allow us to examine the structure of the application. Visually, you will notice two JointJS plugins. You can see the paper scroller, which takes up most of the browser window. And we also have the toolbar plugin, which you can see in the top left corner too. If we click on the help button of our toolbar, it will reveal the dialog plugin, which you can see here. So you might be asking yourself, well, why is all of this important? So we're going to take a look at some code and show you a few reasons you might be interested in structuring applications in this manner. If we focus on the sidebar of the text editor, you'll notice some different directories. If you are familiar with some of our other applications, you'll see at least one folder which we use quite often, and that's the shapes folder. So here we define anything related to the JointJS paper. So as we are creating a Mindmap application, naturally we find a custom idea shape located here. If we open this file, you can see we create a custom class, which is called idea, which simply extends the element class in JointJS. Elsewhere, you may not be familiar with some of the directories, so let's start by looking at the entry point for our application. So in this file, we have a few imports at the top. We have an import of the wrapped CSS from our node modules, and we also import the application specific style sheet style.css. So here we have some general styles related to HTML and body tags. We also have some styles related to the plugins. So here we have toolbar and also the dialog, which we mentioned earlier. So as this is maybe not so interesting for you, we can return to the index file. So on line 4, we import the application class, which we will talk about more later. On the next line, we create an instance of this application class and we pass it the HTML element. This element will be the parent container for application. And lastly, we start the application by calling the relevant method on this instance, which is nameStart. So as you can see, this code is quite minimal, so it's nice to have this concise code as the entry point for application. As we have mentioned one class already, let's examine our classes folder. So here we have two classes. We have our controller class and our app class. The nice thing about the classes is that they are very flexible, so we can instantiate them anywhere in the application. So let's open the app class and take a look at it in more detail. The app class keeps a reference to every single plugin. So all of the properties are public, so whoever has access to app also has access to all of the plugins. So app has several important methods. Here we can see start and stop. When we call start, all of the plugins are created, and when you call stop, you clean everything and remove all instances. In the plugins function, you can see we pass the element, which is the container for application. So let's look at this function in more detail now. The code in this file probably looks more familiar to you. So we create our graph and then we create our paper. We also append the paper scroller to our HTML container element. And if you are now wondering how some of these configurations are so short, you have noticed one of the interesting structural differences from the typical JointJS application. So in this application, we have actually created separate configurations. So if we open paper.js, you can see we are exporting our paper configuration from this file. So you'll notice some of the typical paper options here. So as you can see, it keeps the plugin functions nice and short, It allows you to focus on the code rather than polluting this file with lots of configuration options, so it's quite nice to read. Let's return to the second class that we mentioned earlier. So this was the controller class. The controller class is basically an instance which can listen to other objects. In our case, we are listening to plugins. So it's possible to create different controllers for different objectives. If you want users to click, zoom, and generally navigate around your application, you can create a view controller. Or if you want users to be able to edit and manipulate data, you could create an edit controller. So you could see how this would be useful on a permissions level in any application. And in the Mindmap application, we extend this controller class to create a view and edit controller. So you will be able to see examples of those there. And of course, you can create any type of controller that meets the needs of your specific application. In our simplified application structure here, when we start the application, we create an instance of each controller. And when we stop the application, we stop listening to each controller. And as you can see here in the simplified version, we just create one instance of a view controller. So let's look at the view controller in more detail. So here we can see the view controller. The controller basically shows you application logic, the functions at the bottom of the file, the event handlers. These basically show you high-level logic, so they're very short and human readable, and that's by design. So for example, if a user clicks on the toolbar help button, we can see quickly that that should show the help dialog. In our example, we have two functions, the handler for the toolbar help button, which we mentioned, and also a handler for clicking on a blank paper area. So this should start panning our paper scroller plugin. So you may be wondering, well, why is this interesting? Earlier we mentioned one structural difference was having configurations in separate files. Now we come to one other structural difference in this application. So you may be used to defining events in JointJS, similar like the following. So while this is correct, in this example we bind the event handler to the paper, but if we remove the paper, we actually lose the event handler. So while this is perfectly correct, creating a separate entity like a controller to be responsible for this part of the behavior is certainly beneficial and provides you with more flexibility if you would like to remove just some of the actions in the future. Now let's talk about actions in more detail. So if we open the dialog.js file and take a look, so actions contain the lower level logic for our controllers. The great thing about these actions is we can use them in many different places in the application and in many different controllers if we want to. So you might notice in the dialog actions that a convention we use is to pass the app as the first argument and then any remaining arguments if necessary. So the app as the first parameter allows you to grab any plugin you need in the action. If you look at the open dialog action, for example, we are grabbing the keyboard plugin. If we return to the view controller quickly, the way the controller class is written is all of the handlers will automatically receive the app as the first parameter. To round up talking about the different directories, we can mention the shapes folder once more. So we already mentioned the custom idea shape, which extends the element class briefly, but we can place more things in the shapes folder too. If we have some built-in shapes or even custom connectors and anchors, all of those can be located here. If it's related to the JointJS paper, you can place it in the shapes folder. So one file that didn't get its own folder, but is still important nonetheless, is the theme file. So if you are used to the idea of custom properties in CSS or variables in Sass or design systems in general, you can consider theme to have similar functionality. So in this file, we define some attribute values that we use throughout the application instead of repeating the same code everywhere. So if we want to change a value, we only need to change it in one place at a high level. So it allows us to have a nice entry point for adjusting our app visually in a controlled manner, all in this one location. So now that we have examined the structure of a JointJS Plus application, We can now take a look at the official Mindmap application. So this app uses all of the features that we have mentioned so far. It contains separate configuration files for plugins, controllers that are responsible for events, the actions, a theme, and a lot more. The Mindmap application utilizes a tree layout to display our shapes. The shapes you can see on screen are the idea shapes that we mentioned earlier. So they are content driven, meaning their width is determined by the length of the text. And in general, when using the Mindmap application, a user can create a new idea, reposition ideas, and update the attributes of the idea too. For example, its text or its stroke color. So let's play around with the app to get a better idea of the functionality. So we can edit this element via the toolbar. So if we click on the element and click the toolbar color button, this will allow us to change the stroke to blue, for example. We can also remove the image by clicking the image toolbar button. And if the element doesn't already have an image, it will allow us to upload any image we like. Double clicking on the text will allow us to change the text, for example. So we can change this to business process. And if we click on the URL, we can update the URL if we would like to too. As we are working with the tree layout, we can change the hierarchy. So we can click and drag an element and add it as a child of another branch, for example. So if we look at the help dialog, we can see we have lots of keyboard shortcuts for interacting with the Mindmap application. So if we look at the return shortcut, it says add a new idea after the selected idea. So if I wanted to add a new idea after SEO, I can select SEO, press return on my keyboard, and we have added a new idea. And if we want to edit this idea, again, we can change the text, update the stroke color, or upload an image too. Now let's revisit some of the functionality we mentioned earlier in terms of the Mindmap application. So the Mindmap application contains a view and an edit controller, so we will discuss those in practice. So the view controller allows the user to zoom or to navigate around the application, etc. And the edit controller allows us to change or update the attributes and data. This could be useful, like we said earlier, if some users have permissions to view and some users have permission to view and edit. So let's see what actually happens if we remove a controller. It's actually possible to remove one of the controllers easily due to the structure of the application. All we have to do is comment it out in our app class. So here we can see the edit controller, so we can comment that out and refresh the application. So now if we double click on the text, nothing happens, it doesn't bring us to the edit mode, and we are unable to change the text. Whereas before, when we double clicked, we were brought to the edit mode and we were able to change the text quite easily. Now you can see with one little change, we were able to adapt the functionality of the app quite easily and in a way that makes sense for the architecture and the design of the application. So this approach would become more difficult using the paper on method to bind our events to the paper. So this is why defining a controller to be responsible for this part of the behavior is so beneficial to the application. We could also take advantage of the stop listening method of the controller to achieve the same thing. So if we comment back in the controller, and as we know, the edit controller is the last item in this array, we can grab it and call the stop listening method. So now if we try and double click on one of the items, again we are not allowed to edit the text, we don't see this edit mode. So let's comment this out just for experimentation purposes, refresh the application and try that once more. So now if we double click, you can see we are brought to the edit mode, so we can change the text quite easily if we want to. So the Mindmap app actually uses this functionality when we press the help button on the toolbar. So we don't want the users to be able to do any actions while they're looking at this help dialog, so we stop listening to the controllers during this process. Since we are looking at a tree layout, we can examine the actions related to the tree. So in this file, you can see we have quite a lot of actions related to it. A tree layout has certain rules. Every element only has one parent except for the root. Because we know this, we can extend the graph API and create a function to return the parent element, for example. So you can see this get parent functionality in the add next sibling idea function. So as we have separated our actions nicely, we can take advantage of these actions throughout events in our application. So a typical use case might be to add an action for adding an element in the mind map. So we have shown this earlier. If we select an idea, we can press return on our keyboard and this adds another idea, adds another element. But we could also use this action in the toolbar if we wanted to. And finally, if we look at the three actions one more time, you can see the convention we mentioned earlier of always passing the application first to all of these functions. Let's return to a few other ideas we talked about earlier. So again, we can look at the separate configuration files. We already looked at this paper configuration, but obviously in the Mindmap application we have a few more. So let's look at the toolbar configuration. So you can see it's quite long. It's really nice to have this separately and allows us to focus more on the plugin instances when we create them rather than being distracted by some long configuration. Another interesting point we talked about earlier was the theme. So let's try to update a value in our themes just to see the advantage of this visually. So here we have some variables which change some attributes throughout the application. If we look at the diagram quickly, we have this gap between our siblings. So we could maybe increase this value just to see how it looks. So we can see we have this 3 sibling gap variable. So let's increase the value to 30. Save and refresh the application. So you can see this is very valuable in terms of maybe a design system. It gives the user a lot of control and power and allows them an easy entry point to change all of these values in one place too. One other addition to this application is how the command manager works. So this is the undo redo functionality. So by default, the history in the command manager works by storing all the changes in the graph. So as we work with a very specific layout in the Mindmap app, it's actually not necessary to store everything, so we can be quite selective about what we add to this history. So let's look at an example. If I take the marketing element and drop it over to the left, you can see there was lots of positional changes. So usually those changes would be added to the history, but because we have a tree layout, the only thing we need to store actually is the direction. The important change is if this direction is left or right, L or R, and then our layout can be simply called again. So we don't want these position changes of all the elements to be in the history. We can just add the direction change to the history, call the layout, and it will make the necessary changes to the position automatically. So that's another piece of functionality you might like to adopt for your own JointJS Plus application. So as the video is getting quite long already and we've covered a lot, I think we can start to wrap it up here. So I hope the video was useful for you. This certainly isn't the only way to create applications with JointJS Plus, but the approach used here is certainly one that can prove useful for you. You can definitely adapt and improve on the structure to meet your own specific needs. And if you just want to explore the structure and choose just a few of the ideas here for your own app, you can dive into the code in the JointJS Plus Mindmap application. So thanks for watching.